After posting my 13K plus record score in 3D Mapboard Royal and the YouTube video about it, some of you guys asked that how I prepare my graphics cards for liquid nitrogen and sub-zero overclocking generally. So I will show that to you today. So my overall method to insulate graphics card is pretty much the same as I do with motherboards. So if you watched my original motherboard insulation guide from last year, the overall procedure is pretty much the same. So all the gear that you need to insulate your card is pretty much on this table. So you obviously need the actual graphics card itself. So in this case we are using the 2080 Ti Kimpin, which I just removed from the actual GPU container from my previous LN2 session. Then of course you need the actual GPU LN2 container itself. So in this case I'm using the Kimpin Cooling Tech 9 Icon, which is the GPU pod that I would get right now, as there aren't that many realistic options on the market, and this supports all the generations pretty much, and it has ample contact surface area even for the largest GPU dies. Then you need high quality thermal paste to use between the GPU and the actual LN2 container. I would use some high quality one like Kimpin Cooling KPX or Thermal Grizzly Cryonaut Liquid Helium Edition, as especially KPX I have been able to get to coldest temperatures so far. So the coldest temperature I managed on the 2080 Ti Kimpin with KPX was minus 174 before it cracked. So that is the best temperature so far, and if I used worse thermal pastes I would crack much earlier. So that's one of the reasons to choose something like KPX, especially if you are running a very high powered graphics card like, well, pretty much all the latest generations from Nvidia. They use really a lot of current when you run them on LN2 at high voltages and high GPU clock speeds. Then for the actual insulation materials you need Vaseline as always. Then you need Armaflex or similar brand 3mm thick closed cell foam insulation tape, and then just normal your shop paper towels. Then when you run the cards on LN2 at really high voltages and clock speeds, the MOSFETs really heat up as the load is so high on the graphics cards. And if you cannot use, or well, most of the time you cannot use the stock cooling fan on the VRM, so you have to use a third-party one to cool the main VRM heatsink when you run the card on LN2, as the LN2 only cools the actual GPU. You should use a really high-powered custom fan sandwiched directly onto the VRM heatsink. So I would use something that has at least 100 CFM. Good options, in my opinion, are the Scythe Ultracast 3000 or quite realistic fan from Delta. So in my example I was using this Delta AFP 121-2 VHE. So the good thing about this particular cooling fan is that it can produce around 150 CFM of airflow, and it only draws 0.9 amps. So like the safe limit for a motherboard 3 or 4 pin fan header is around 1 amp. So those fastest 120 millimeter cooling fans from Delta, they can draw multiple amps through the wires. I think the Delta MegaFast one, that is 120 millimeter sized fan, and it can push 250 CFM of air, but it draws almost 4 amps through the 4 pin or 3 pin wires, and that is quite risky if you put that on a motherboard cooling fan header. So I would not get something like that. So if it draws less than 1 amp, that is good. So that's why I would choose something like this or the Ultracast 3000. With some models you can use the actual the default cooling fan for example on the 2080 Ti Kimpin, but it's not often that good if the fan speed is not locked to 100% in the custom BIOS that you use on LN2. So if the fan speed is auto by default on the BIOS, it's not always that convenient to use when you have to always set it to 100% manually. So that's why using a really high powered custom fan is often much easier. So but other than that, you don't really need anything else. So the first thing you want to do when you insulate your graphics card for the first time is to get the card totally naked, so the bare PCB. So remove all the components like backplate and all the cooling heatsinks on the card, so that you can access all the small components on the card, especially the MOSFETs or the VRM part itself, and etc. So the riskiest part on a graphics card when you run the GPU on LN2 is the actual GPU and the memory chips around it, and the VRM part on the graphics card. So when you run the card on LN2 at very cold temperatures, and if you sit at idle for long periods of time, the card, even the VRM area might freeze if you stay at idle too long. And when you start a benchmark, like a really heavy one, then of course the VRMs start to heat up. Then all that ice begins to melt, and that creates condensation water that could short something, or in the worst case kill the whole graphics card. So that's why, and this also means motherboards as well, I always insulate the MOSFET area thoroughly with Vaseline. So you really want to get a good layer of Vaseline directly around the actual MOSFET or the VRM components. So just remove both of the VRM heatsinks. So in this case, as I just removed the card from my LN2 container, as this is pretty much taken directly from my previous LN2 session, I will not do it now. So get the card to bare PCB, and then once you have done that, you pretty much just want to use your Vaseline and get a good coating all around the key components on the card. So you should insulate all of the area on the card left from this point on the card, so which I'm pointing now. So after the actual MOSFETs themselves, the temperature doesn't really get that cold, because, well, this area here heats up, so that kind of blocks the freezing right from this point. So you don't have to get your insulation all the way to the actual 8-pin connectors over here. So you just pretty much want to just get a good layer of Vaseline all the way from here to all the way over here. And once you have done, or once you have coated the areas thoroughly, you want to use some heat source, like for example a heat gun or a hot air soldering station, to melt the Vaseline so that it can get to all the small components and caps on the card. So what could happen when you run the card on LN2 is that some moisture builds up even underneath the GPU or the memory chips, and that can cause artifacts or complete instability on the card. So you really want to get a good layer of Vaseline so that you can see that it kind of creates that some kind of like solid layer all over the edges of the different components. Then one thing, and one of the other riskiest parts for graphics card insulation, is the actual PCI Express slot. So for example, if you crack your thermal paste, you have to heat up the card to, let's say, -20 pot temperature, so that the card can get to, or the GPU can get to positive temperatures for the thermal paste to resettle. What can happen is that some of the ice that is on the card, it starts to melt, and then it runs down to the actual PCI Express slot. This has happened to me many times. So PCI Express slot area and the the direct area around it on the motherboard is something that you have to pay attention to carefully as well. So I always use Vaseline on the PCI Express contact teeth, as well as in the slot and the areas around the slot. Using just Vaseline on the back side of the board directly behind the PCI Express slot that is used is often enough, so I don't do anything else than that on the back side of the board. But I use Armaflex and paper towel around the PCI Express slot to minimize the freezing. So after you have coated the front side of the card, use some like cotton pad or similar to clean the top part of the MOSFETs, so that you can get ample thermal contact with the actual MOSFETs and the VRM heatsinks, as they have to be cooled. So if you just have a Vaseline on them, it harms the contact a little bit. So you want to get good layer of Vaseline everywhere around the actual MOSFET, so you can see that it has a good layer of it, but just clean the top part of the MOSFETs for good contact with the heatsink. So you should use something like CRC Precision Cleaner Pro to clean the top part of the MOSFETs. It really gets off easily with CRC and with a cotton pad. So you don't really need pretty much else. So for example, on this card generation, I don't use anything else than Vaseline on the front side of the card. I could use some small sheets of the Armaflex insulation tape around the GPU, but I did not find it necessary, so I just did not do it. So once you have done that, you pretty much just want to take your thermal paste. Of course, make sure that the surface of the GPU as well as the pot is completely clean, and then you just want to put ample layer of thermal paste on the GPU itself. So just like you have seen on their Bauer's videos, you have to use a lot more thermal paste on Subzero compared to air or water cooling. So it doesn't really matter that it has too much thermal paste in most viewers' eyes, because all the excess thermal paste will be pushed to the sides anyways by the pressure of the container. And when you have ample amount of thermal paste even around the actual GPU, so you could cover the whole actual GPU part with thermal paste, so from this side to all the way here, it improves the thermal transfer a little bit, and it reduces the risk of thermal paste cracking a little bit. So that's why it's very wise to use a lot of thermal paste, much more than you would use on air or water cooling. So once you have done that, you pretty much take the card and the GPU pot, place it over here, and just make sure that it aligns with the holes. I'm using the inner holes this time, so I'm not using the outer holes. I think you can get a little bit better overall pressure just behind the actual GPU when you use the inner holes. So you could use even both of them. So that could be, or well, you could call that some kind of 8-point mounting, although it's not the common 8-point mounting, as the pressure is still applied only from the corners, not from the actual sides as well. So that's how it looks like pretty much. So now you have to insulate the backside of the card as well. So just again use Vaseline as before and cover all the areas from the I/O part to the area where the MOSFETs end. So on this card it's pretty much where you see these polymer or tantalum caps over here. So you don't have to go with Vaseline right from this. So you don't have to cover the card all the way to the PCI Express 8-pin power connectors. So once you have done that, use the heat gun or hot air soldering station again and melt the Vaseline so that it really gets everywhere. I mean, all the gaps over here between these components, they are very small. So a small water droplet could be hiding somewhere between the components and short something, and that could show up as artifacts, some weird graphics card shutdown issues or similar. So it's wise to really get it everywhere so that you have the best protection against condensation. So after applying Vaseline, you want to take the Armaflex or similar brand close-cell foam insulation tape, and you need to cut pieces so that it covers the card completely from the top side to all the way where the PCI Express golden teeth start. So you can use, or you can pretty much measure by hand, so you can just take the piece or the actual tape here and just mark the spot with your thumb where you want to make the cut with scissors, just like that, very easily. So the thing about these closed cell foam insulation tapes is that they have really tough glue. So the good thing about them is that they usually stick really hard and quite well to the target surface, even when there's Vaseline on the actual surface. So if I did not have Vaseline on this part of the card, then after that it's really hard or almost impossible to remove the insulation tape after the session without tearing it to pieces. So the good thing about applying Vaseline is that you can remove the insulation tape in one piece after the session. So that's what I mean, just saying, so that the glue is really tough on these, so just be careful. This is why I recommended to use normal electrical tape on the actual graphics or on the actual LN2 containers first before using this insulation tape, so that you can, if you ever want to remove the insulation from the pot, you can do it without tearing it to pieces, because after that it creates this really annoying like mess of glue on the actual surface. So it's really annoying to remove the glue remnants from the target surface. So just saying, this is not Armaflex branded insulation tape, so this doesn't have as good like contact to the target surface as Armaflex branded insulation tape, but this was some cheap alternative I found from a local store, but it does the job anyways. So after applying the first piece, you want to cut the second piece, and of course you have to get the rods through the insulation tape. So you can just do it like that, mark it again with your thumb and cut the second piece. It's actually easier to do this before mounting the pot on the card, so you could do this, or you should do this before you mount the card on the actual container, but I was a bit lazy this time. So that's how it looks pretty much. Then for the last piece, of course, since it's thinner now, you cannot use the whole width of the tape, so you have to mark down, or well, first of course cut the length of the last piece of the insulation tape, and once you have done that, you want to mark the second spot where to cut with your thumb, so you can make the piece smaller. And now we can get the last piece onto the card. You can see that this particular insulation tape isn't that good, so the glue is not that tough on this compared to the actual Armaflex branded one. So you can see that the start and end part of the insulation tape are starting to get off from the card PCB, because the glue isn't so tough on this compared to a real Armaflex branded one. But anyways, this does the job for this demonstration video. So I would recommend you get real Armaflex branded one or something better than this when you get your supplies. Now the next piece is extra. So pretty much, or most of the GPU pots that you can find on the market don't use a backplate. So at least all the Kimpin ones, they don't use a backplate. So now you would just, if you did not use a backplate, you should mount the card completely to the pot first. So tighten the pot down, or the card down to the pot, before putting these pieces of insulation tape. But in this video I'm showing you something extra. So if you have a piece of metal, you could make a backplate quite easily, like I have done to this one here. So this is some backplate for other GPU cooling unit, but I drilled these holes over here on each of the corners so that it can fit these mounting rods of the pot. So using a backplate like this, I think it adds a little bit extra like support directly behind the GPU, so it can make the overall mounting a little bit better, at least in my tests, based on the how the thermal paste has spread after mounting and removing the card from the pot, so after session. If you use a backplate like this, I recommend that you use a layer or a few layers of paper towel between the insulation tape and the backplate, just to make sure that if the insulation tape tears into pieces when you are running it, that the backplate just will not short anything on the backside of the card, as that could damage something, as the backplate is well, it's always metal, so it could short something on the card. So just for extra security, add a few paper towels just like this to make sure that it cannot short anything. And after that, you just put the backplate behind the card like that, and you start to tighten down the card to the pot. So do it like as always, so just get the thumb nuts quite loose in first, and tighten the opposite corners at the same time to get even pressure across the whole GPU. Now, I do not recommend over tightening the pot with pliers, like what happened with my 9980XC. There, the PCB of the CPU bent due to too tight pressure from the pot. With cards like this, if you over tighten the pot with pliers, you technically could damage something, or you could damage the solder balls underneath the GPU and make the whole graphics card unusable. So there is a real risk involved, so I would not use pliers at all. Or if you really want to use them, do a like quarter of a turn max, but overall I would just not do it. Maybe it can help with the actual contact, but it's really risky business, so I'm not doing it myself, as these cards are really expensive. Of course, I think no one wants to make or render them useless. So don't use pliers, just get them tight by hands like this. So that's how the card looks like. So you don't really need anything else apart from this in terms of insulation. So Vaseline does most of the job, but adding insulation tape and paper towel like this, it really helps a lot on the back side. You could put some insulation tape on the front side as well, so around the GPU and over the MEMS. It is usable, but I just don't see it necessary, as Vaseline is the most important thing for the insulation in my method of insulation. So after this, you just take the card and place it onto the motherboard. I will demo it shortly with the Z97 OC formula. So once you are ready to mount the graphics card to the actual motherboard, I would put one additional layer of Vaseline to the both sides of the actual PCI Express connector, just to have the best safety against condensation. As I said before, if any of the ice starts to melt on the graphics card, so for example if you are heating the pot back up, the water can easily run down the PCB and fall into the actual PCI Express slot or the area directly around it. So I would insulate the area around the PCI Express slot thoroughly on the motherboard as well. So use Vaseline all the way around the PCI Express slot where you are mounting the card, and also cover the PCI Express contact pins on the back side of the board. And if you are placing the whole motherboard on a piece of Armaflex, that is also very good. Then use something like Armaflex in between the first and second PCI Express slot to form an airtight seal, just like I'm doing here, and stuff maybe like paper towel over here. And if you are using the CPU on LN2 as well, then you should cut a piece that covers the entire CPU socket area so that it forms an airtight seal from the first PCI Express slot to the VRAM parts and to the memory slots over here. So that this side of the PCI Express slot is also covered. So that's pretty much it. One thing about mounting the card to the motherboard is that there's always a gap between the actual graphics card container and the insulation area over here. So you should always support the GPU container with something so that it does not bend the actual graphics card when you mount it on the motherboard. So if you are using a bench table, you should always use the PCI Express bracket over here to support the card to the bracket, and also use something like paper towel or other pieces of Armaflex so that the GPU pot sits on it, so it doesn't have to bend the actual graphics card PCB, as bending could cause numerous issues when you run the card on LN2, so it could cause some weird instability issues or similar. So I would just use something like, I often use a few pieces of paper towel just before the first PCI Express slot, just like this. And then I pretty much just mount the card. Well, now I can't do it because the bracket is touching the table first, but you get the idea anyways. So once you have mounted the card successfully, then you have to run the power cables, and I would attach the cooling fan directly onto the VRAM heatsink with rubber bands or similar, so that it really is sandwiched directly onto the VRAM cooling heatsink. So if you watched my Port Royal video, I used 3 rubber bands to attach the cooling fan directly to the card. So if you just use one, it can easily like break when the card starts to freeze. So I would use at least 2, but 3 is good. So that's pretty much it. There's nothing really else about insulating the card and mounting it to the motherboard. So if you have any questions or comments about this, then please drop them down below. I can happily recommend the Kimping Cooling Tech 9 icon for any LN2 use on multiple generations. So it's easy to use and easy to insulate. But yeah, so other than that, hit the like button if you like this video and subscribe to my channel, and see you next time.